What's up guys, and welcome to this video about Kotlin coroutine flows. In this video we are going to build an own flow chain where we emit values and apply a lot of operators on it, also do context switching from the data layer over the domain layer to the presentation layer, and then we finally collect the values and can show the user a corresponding percentage value because we will simulate some heavy data processing and always update the UI how much process we actually have now. Let me quickly show you this in this example app. We will click on Start Export, and then you can see that there's a heavy processing task in the background, and we get the corresponding percentage value so that our UI is really responsive. Alright, okay, I'm in an empty Jetpack Compose project. In case you're using XML for your layouts, this shouldn't be a problem since we only have a simple button and a simple dialog which shows the current percentage. The rest of the logic will be in our data layer and in our view model. The first thing we want to do is to build our flow actually. We want to have a root where all the values get emitted, where we can then apply different operators until we collect all those values. For that, we will go to our root package and create another package called data, because we will do this in the data layer. We will simulate some heavy data processing, which normally happens in the data layer. And we will create another package inside the data layer called converter, because in this case, we have some converting data logic, which we will consider as our long processing task here. In our converter package, we can create a Kotlin class called user data converter. And normally in terms of clean architecture, I would put this behind an interface and then do some dependency injection with Dagger Hilt. But I think for the sake of this tutorial, it's fine to use a plain class. In here, we will have a function convert user data. This will be our flow builder function. This takes a user data list of type float. This is not further specified, just some user data here. And it will return a flow of type data converting info. This is a data class we will define after we applied this flow block here. And as you can see, we can now create a flow. All those functions here return a flow. And we will use this flow builder because there we can emit multiple values. We could also just use this flow off, for example, and provide a value like this, but this would only provide a flow of one single value. And if we use this flow builder, we can let's remove these arrows, and then in here we can just say emit and emit again, and for loop, for example, which we will have here, we will emit values over time. Let's create this data converting info data class down here. Normally I would also put this in a separate file, but I think for this tutorial this is also fine. This will contain a value converted data amount of type integer, and this will indicate how much data we actually converted, and depending on that we can apply a formula to calculate the current percentage. And let's also import a flow to get rid of this compiler error. And then we will start with a var already converted values, which is equal to 0 by default. And then we will say user data dot for each. And in here we don't need actually the user data because we will just simulate some heavy processing. We will say for I in 0 until 1000. We will have a value j is equal to I dot to double power of 2, for example. Just some heavy data logic. Later on we will pass a list with 1 million entries, and then this will take a while, like 5 or 10 seconds or something like this. And for each iteration in this for each block, be careful, not in this for block. In the for each block for our user data, we will emit a value which indicates how much we actually converted already. Let's say emit data converting info. Converted data amount is equal to plus plus already converted value. This will increase the already converted values each iteration in this for each loop by 1, and will also emit this value so that we are always up to date how much values are actually converted. And then we can apply different calculations to get the current percentage and to show the user the current progress. Let's go to our repository class now, which will also have a function and subscribes to this convert user data flow builder function. and applies different mapping operations like the percentage calculation, which gets then provided to our view model for the UI. In our data package, we will create another class called user repository. And again, I will just make this a class. In a real-world application, of course, we should make a repository class an interface in the domain layer and then confirm to this interface in the data layer or realize this interface in the data layer in terms of clean architecture. We will have a function generate user data. This will also take user data, list of floats, which is not further specified, and this will in this case return a flow of data progress info, which is a data class which we don't have yet. And the reason why this function is called generate user data and our converter function was called convert user data is because maybe in a real world application you would have some raw data and you first need to convert them to get the generated data, and then you can save them in a file or something like this. So the repository is responsible for generating the user data, but uses the user data converter for converting the user data. This is where the name comes from. Let's create our data class for the data progress info, and this will take a value, progress percentage, which will go from 0 to 100 later. And of course, we could also make this flow return an integer or emit integer values. But maybe you also want to provide additional information, then this should be, of course, a data class. Let's also import flow, and then we can open this function block. And first of all, we need a values for 1%. And this will be equal to user data.size divided by 100. So if this user data list has 1 million entries, then this would be divided by 100 and the result would be 10,000. And we would need to process 10,000 values to actually get 1% done. Then we need access to our user data converter, which we can get from the constructor private val user data converter of type user data converter is equal to user data converter. So we will simply create the object in the constructor. Not the best practice, of course. You should use some kind of dependency injection framework for that and also use interfaces. But as I already said, this is fine for now. In here we will say return user data converter dot convert user data. We will pass the user data list, and first of all we wanna filter values because now we have a flow returned from here and we can apply different operators on this flow. And first we will start with the filter operator. If we have a closer look at this filter function, we can see that we can invoke it on a flow of type T. In our case, the type T is data converting info. And then we need to provide a predicate, so some comparison which return either true or false. And then this filter function will again return a flow of the same type T. So it will just filter out everything that does not match this given predicate. And for our case, we will have a check on the converted data amount. We will say data converting info so that we don't need to invoke it with it. We will say data converting info dot converted data amount modulo values for 1% is equal to 0. In case you don't know what this modulo operator does, it just checks if this converted data amount is dividable by this values for 1%. So let's take a quick example. We have a converted data amount, for example, 50,000. Then our values for 1% would be, for example, 10,000, and it would result in 0. If this converted data amount would be 15,000, so it's not divisible by 10,000, then this modulo operator would result in 5,000, and this would return false, and so the value gets filtered out. And we still have a problem because we have a required flow of data progress info, but currently this filter function just returns the same flow that it actually gets of type data converting info. So we need to do some mapping. And for that, we can apply the next flow operator, which is called map. Let's open this block, and as you can see, we again get the access to our data converting info like this. And let's check on the documentation for map. As you can see here, we can invoke map on any flow with type T, and in our case, type T again is data converting info. And then we need to provide a function which maps our type T to another type R. So we can change the data class or the type of our flow, because it will return a flow of type R then. And for our case, we will say data progress info, and we will pass for the progress in percentage our data converting info dot converted data amount divided by values for 1%, because we can we can be sure that this is divisible, because we already checked it in our filter operation here. And then the arrow is gone, and we successfully mapped a data converting info object to a data progress info object, which now holds the current percentage of our progress. In case you want to do more mapping, then you can just apply the map operator again, and also again the filter operator on each or something like this, because all those operators have the same principle. They take a flow and do some action or some mapping, some filtering on it, and then they emit a flow again. So the possibilities are endless here, and we can build really beautiful flow chains. The last operator I want to apply is the flowOn operator, which takes the coroutine context, which we will pass the dispatches.io context. Let's check on the function definition. We have a flow of type T again, where we can invoke this flowOn, and then it also returns a flow of type T. So nothing changes here. It just takes the coroutine context, and we don't do any processing on the values. And let's read this first sentence here. It changes the context where this flow is executed to the given context. So that means that this flow is executed in the context of dispatches.io, because we will do heavy data calculations here, and this should be done in dispatches.io coroutine context. And be careful, this does not mean, if you, for example, apply some other operators, that this here is executed in the dispatches.io context. You need to have a look at this, what's kind of below this flowOn operator. So all this stuff here is executed in the dispatches.io context, and also this here where the flow actually gets created. So everything what's below this flowOn context switch. Alright, okay, let's go to our root package and define our view model where we collect our flow now. We will call this user view model. This will inherit from view model, and we can also pass the argument in the constructor private val user repository. We will straight initialize it here like we did in the user repository itself with the data converter. In the view model, we will define state vars for our UI. The first state var will be our progress state by mutable state of 0f by default. We will make this a private set so that we can only change this value inside our view model. Then we need to import this get and set values for the mutable state of delegate. And we will have a var is loading by mutable state of false, and we will make this also a private set. And then we initialize this view model with some user data. We will say private val user data is equal to mutable list of float, and this user data list is empty by default. In the init block of this view model, we will say for I in 0 until 1 million. We will say user data dot add I multiplied with 2f, for example. Just some simple example user data. Then we can say function start generate. This function can be invoked from our UI later. This is why it's public. We will say is loading is equal to true. And now we can collect all the flow values, but let me quickly show you something first. We will say user repository.generate user data. We will pass our user data mutable list, and then we could apply, for example, the onEach operator. And in here we can say progress state is equal to it.progress percentage, for example. And I think we have type error. Okay, let's change this progress state to integer. And if we let it stay like this, then nothing would happen. We wouldn't collect anything, but you could assume that you get all the values in this onEach block because all the values get emitted. This is true, but only if you also collect this flow. This onEach is just an operator. It does not collect the flow. Collecting a flow means making it hot, because by default a flow is cold. So a flow doesn't do anything until it's collected. And right now it's not collected. If we say collect now, then the flow would be collected and becomes hot and collects and emits all the values. But for this collect function, we need a coroutine scope, because this is of course a suspend function. And for that we will say viewModelScope.launch. And now we can copy and paste this here. And then the arrow is gone, and this would of course work. We would set the progress state to the current progress percentage, but we shouldn't use onEach for that. We can do this in this collect block. onEach is more like an operator where you can do additional action, because it just passes the emitted values through. And for each value, you could apply an additional action. And we should set the progress state inside the collect operator. So let's just remove this onEach block. And for the sake of additional operators, we will also apply two map operators here, so that you can also see that we can apply them in the view model, in the presentation layer. And in here, we will say data progress info, for example. And we will say its.progress percentage multiplied with 10, and then we will map it again. We will say its.progress percentage divided by 10, and then we get an integer provided here in this collect block, and then we can set our progress state. Of course, this is nonsense, these two map operators, but you can see that we can also apply them here, because this whole flow is a large chain, and it isn't limited to one single file, to one single class. It's limitless until it's finally collected. All right, okay, the last thing that's left is building our UI. Let's go to our main activity and first create a private val view model by view models of type user view model. In here we can remove this surface and also this composable preview examples. We will have a box which takes a modifier, and let's import this box here. This modifier will fill the max size. The content alignment will be alignment.center. Then we can open the box scope, and we will just have one button with an onClick method. And in this onClick method, we will invoke the viewModel.startGenerate, and the text of this button will be start export. And the last thing that's left is our dialog. We will go below this box and say if viewModel.isLoading. Then we will invoke a dialog for the onDismiss request. I think we need to import dialog first. The onDismiss request, we just pass nothing. And then we will have a simple column where our progress indicator and the corresponding percentage text is. And for the modifier, we will say modifier.fillMaxWidth. The vertical arrangement will be arrangement.spaced by 15 dp. The horizontal alignment will be alignment.center horizontally, import dp. Then we can open the column scope. And in this column, we will have a circular progress indicator. The color will be set to color.white. Then we will have a text. And for this text, composables text, we will say processing user data. And in here, we will say viewModel.progressState. And then we will close the parenthesis and apply a percentage sign and 3 dots like this. And the color will be color.white again, and the style will be materialtheme.typography.body1. And I think then we are good to go to launch this. All right, okay, let's click on Start Export, and then you can see the percentage value gets increased over time, because our flow always emits the current processed values. And this does not dismiss after it's finished. Let's go to our view model. and in here we will set isLoading is equal to false, and also the progress state is equal to 0 again, and then we can try this again, and this should be dismissed after 100%. Maybe you want to indicate some CSV processing which needs to be converted to get ready for export or something like this. And yeah, now this works very well. One last thing that I want to mention is regarding the different execution contexts. In our repository, we had this flowOn operator where we switched the context to dispatchers.io. So everything that's below this flowOn operator gets executed in dispatchers.io. In our view model, we don't have this flowOn operator because here we launched this in the view model scope, so in the coroutine scope, and the view model scope belongs to dispatchers.main. So everything that's executed here happens in dispatchers.main context. Alright, okay, this was it for this video. Thank you very much for watching. I hope you enjoyed it and you learned something about coroutine flows, different operators. In case you want to learn more about other operators or also how to define an own operator, then let me know this in the comments, and then maybe I will do a video about it.